Welcome back to this new video about semantic kernel. In this video, we are going to look into the exact sequence of requests that semantic kernel uses when you use an agent. And as usually, you find all the code in GitHub, and let's immediately dive to the code where you can see in the very first block of the dib of my polyglot notebook. As you can see, I've used the standard import routine, and then I've added import routine for my custom code, and especially my common full DI. If you go to look into the code, you can find that this code will contain a series of classes that are used to intercept all the interaction between semantic kernel and the OpenAI API. I've added an instruction to dump the version of the framework we are using, and be sure you're using the framework 8 because all the code works only if you have .NET Framework 8. And since the Polyglot Notebook uses .NET Interactive, if you see as an example that you're using .NET 7 or even an older version, you need to be sure first to install the .NET SDK, the newest version, the 8, and then you can use .NET Tool to update the Microsoft .NET-Interactive, because this is the .NET tool that it's used inside Visual Studio Code to work with Polyglot Notebook, so you can have the latest version of the .NET used. And now you can proceed with the standard code where I use kernel builder, you resolve your kernel, and then you are using connector OpenAI, and then you get the iCheck completion service, and then there comes the code where I'm invoking the agent. Nothing different, it is very same code I showed you before, but this time in this example, I've enabled interception, and interception allow me to intercept all the interaction between semantic kernel and the OpenAI API, so I can see how the OpenAI SDK is used to solve a problem with an agent. As you can see from the output, the result is what we expected. We called the plugin to extract the video file. So semantic kernel correctly used large language model to understand the question of the user, understand that it has a plugin that can perform what the user asked to the agent, and so it called the agent. And finally, it returned a list, a read-only single element list of chat message content. So that's a standard chat message content. You can use this code to dump, and this is not my code, this is standard code in which you can simply say, hey, I cycle in all the results that the semantic kernel returned to me, and I want to dump the type of the result, okay? And then I'm gonna serialize the result with some option to write indented to look to have a look at what's inside the result. So if I press play, I have that I have only one result, and the result is the OpenAI chat message content as expected because I'm using the OpenAI SDK. And you have type text content where the audio has been successfully extracted from the video and saved as blah, blah, blah. So as you can see, I really have a tool call, and I really have a role assistant that returns me a text content. And so that's some metadata, other stuff, but actually I have the answer of the agent, and it's correct. The agent correctly extracts the video file. Now you can see this other piece of code that uses my extension that intercepted all the call to the large language model. Basically, it does some parsing of the result, but in this example, I'm simply interested in dumping all the requests and all the response to understand how much requests were done to the large language model and what the large language model answer, and which is the technique used to query the OpenAI API to use tool calls. So you can just press this, and the answer is a little bit too long, so you can open a text editor and understand what is happening. So as you can see, you have a first call in which you simply tell to OpenAI function that you have a message from user role, and the content is the exact question that the user does to the system. But the difference in this situation is that the request contains this tool section And this is really important because the tools section explains to the large language model which are the tools that you can call locally, okay? So you have an extract audio, you have a transcript audio, and tool choice is auto. So the idea is you are asking to the large language model that the user has a question, but you have this kind of tools at your disposal, and you left with the tool choice auto, you left the decision to the large language model if you need to call a tool or other. So the first response is a function call. So in this situation, the large language model determines that to solve the problem of the user, you need to call the audio video plugin extract audio, and it gives you the argument. So this is the power of the large language model, the ability to understand the question of the user and decide which large language model to call. And here it is, Lucifer is coming in the video. Okay, let's say hello. Let's say hello to the viewer. Now, the second request is really interesting because semantic kernel determined that the first answer is call the audio video plugin extract audio, and it called the plugin. Then this plugin gives a result. And so the subsequent request is a chat model. So the first message is the very same message of the previous request. But we have another piece of the chat in which role assistance tool calls. So it correctly, semantic kernel creates a call into the OpenAI API in which actually the chat is composed by not only role user or assistant, but also tool. So the chat is the following one. The user asks a question. The assistant gives you a tool call. So the assistant wants you to call a tools, and then the tool answer this result, okay? So the idea is now this chat is composed by user, assistant, and result of the tool. And it's a little bit more complex and a little bit more interesting. In this subsequent call, I still have all the tools that I have at my disposal. And this happens because I am continuing, semantic kernel continues to create calls to large language model, and the chat goes on using this time tool calls and tool result until the response now is the audio has been successfully extracted from the video file as ctemp.ssh.wav and is role assistant. So this concludes the conversation. Now I've changed the call a little bit to always dump also the full response, not only the reduced form of a response. So I have more interesting things to show. So that's the request, the first request, and we know the request, and we know that the response is a function call, but the full response is this one. So you have finish reason tool calls. So it is telling that the finishing generating output is due to tool calls, and it has a tool calls function and blah, blah, blah. And so after you put the second request, the one with all the result of the first call, we have a message response content. The audio has been successfully extracted, and this is the choices. So it has some blah, 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 and then finish reason stop. So we know from this finish reason that we can stop, and the content, the audio has been successfully extracted. It is good, and it is the role from assistant. So that is the way in which you are interacting with the large language model from semantic kernel. I hope you liked this video, and I'm waiting you for the next one.